Hello, welcome to week 16, chapter 7, lesson 4. It's about properties of logarithm. In this lesson, you should be able to simplify logarithms, expanding logarithm, and also you should be able to apply logarithm rule to uh, find the logarithm scale. Now let's see the content of the lesson. In the lesson content, we are going to see a key concept regarding logarithm. In the key concept, we are going to discuss about the rule or the property of logarithm that help us to simplify and evaluate logarithm expression, and also it will help us to expand logarithm expression, and we'll apply the rule of logarithm to to evaluate or to simplify logarithm expression, uh, and then we'll see using the logarithm scale. This is the application of logarithmic expression. And as usual, at the end of each lesson, you should each solved problem, you should be able to solve the question from your textbook. Now let's go to the key concept. And the key concept, as I said earlier, it's about property or the rule of the logarithm. For any positive numbers m, n, and b, where b different from 1, logarithm of m times n to the base b equal to logarithm of m to the base b plus logarithm of n to the base b. We call this one product property or rule of product. The second property of logarithm is logarithm of m over n to the base b equals to logarithm of m to the base b minus logarithm of n to the base b. We call this one quotient rule or quotient property. The third one, logarithm of m to the power of n to the base b is the same as n times the logarithm of m to the base b. We call this one power property. The fourth one, which is also very important, change base rule. That means we can write any logarithm in any base. So if logarithm of m to the base n is given, so we can uh, use any base to express this logarithm. So it will be logarithm of m to the base b over logarithm of n to the base b. So we call this one change base rule. And another property that you should know, that logarithm of a to the base a is equal to 1. Just keep this one in your mind. Now, this is about key concept. Now, based on key concept, now let's see problems regarding logarithm expression. Okay, the first problem is about simplifying logarithm. What is the expression written as a single logarithms? Part A, here the expanded form of the logarithm is given. Now you are going to change the expanded form to simple or single logarithm. Here, as you can see, the operation between the two logarithms is subtraction. So in logarithm, subtraction means division. Therefore, I can apply the quotient rule. So it will be logarithm of 32 over 2 to the base 4. Then simplify, it will be logarithm of 16 to the base 4. And again, you can write 16 as a base of 4, which is 4 to the power of 2. And as you can see, since we have the power, we can apply the power property of logarithm, which is going to be 2 times logarithm of 4 to the base 4. And logarithm of 4 to the base 4 is 1, therefore 2 times 1 will be 2. So when you write logarithm of 32 to the base 4 minus logarithm of 2 to the base 4 in simplified form, it will be 2. Let's go to part B. The expanded form of logarithm here also is given. Then we are going to simplify, or we are going to write this logarithm as single logarithm. So the first thing that we need to do, since there is 6 times logarithm of x to the base 2, we are going to apply the power rule. So this will be logarithm of x to the power of 6 to the base 2 plus logarithm of y to the power of 5 to the base 2. And again, the operation between the two logarithms is addition. In logarithm, addition means multiplication, so I'm going to multiply x to the power of 6 and y to the power of 5. So finally I will get logarithm of x to the power of 6 times y to the power of 5 to the base 2. So this is about problem 1, which is about simplifying logarithm. Now let's go to problem 2. Problem 2, the expand, we are going to expand logarithm, meaning single logarithm is given, then we are going to expand it, which is exactly the reverse of the problem 1. So let's see part A. In part A, logarithm of 4x over y is given. Here, one thing you should know that as we saw last week, if the base is not written, which means that the base is 10. So here the operation is division. So in logarithm, as we said, division means subtraction. Therefore, I will apply the quotient rule. Therefore, it will be logarithm of 4x minus logarithm of y. And again, we have another operation. The operation between 4 and x is multiplication, and multiplication in logarithm means addition. Therefore, I can expand logarithm of 4x as logarithm of 4 plus logarithm of x minus logarithm of y. So this is the expanded form of logarithm of 4x over y. Let's go to B. Logarithm of x to the power of 4 over 729 to the base 9. So again, let's apply a quotient rule. Logarithm of x to the power of 4 to the base 9 minus logarithm of 729 to the base 9. And again, let's apply the power rule because we have power. So it will be 4 times logarithm of x to the base 9. Also, we can write 729 as a base of 9. So it will be logarithm of 9 to the power of 3 to the base 9. And again, apply the power rule. It will be 4 times logarithm of x to the base 9 minus 3 times logarithm of 9 to the base 9. And as we said earlier, logarithm of a to the base a is 1. Therefore, logarithm of 9 to the base 9 will be 1. So we'll get 4 times logarithm of x to the base 9 minus 3 times 1. So we'll get 4 times logarithm of x to the base 9 minus 3. So this is problem 2. Now let's go to problem 3. Problem 3, we are going to apply the change base rule. Okay, as we said in the key concept, we can write any logarithm with any base. So using the change of base formula, so let's see what is the value of the expression logarithm of 27 to the base 81. Here 27 and 81, they can have a common base. We can write with a base of 3. So let's write 27 and 81 with a base of 3. So logarithm of 27 to the base 3 over logarithm of 81 to the base 3. And again, 27 means 3 to the power of 3 and 81 means 3 to the power of 4. Okay, and apply power rule. Then logarithm of 3 to the base 3 is 1, and logarithm of 3 to the base 3 again is 1. Then finally we'll get 3 over 4. Let's go to B. Logarithm of 36 to the base 5. Here we can write this logarithm as a base of 10. So it will be logarithm of 36 to the base 10 over logarithm of 5 to the base 10. This time, because they don't have a common base, or we cannot write 36 as a base of 10, so directly this time we will use a calculator. You can use a calculator and simplify, and it is approximately 2.23. So this is the change base rule or the change base formula for logarithm. Now let's go to problem 4. This is the application of logarithm. The pH of a substance equals minus logarithm of the concentration of hydrogen ion. where the concentration of hydrogen ion is given in this problem. We have two substances. The concentration of ammonia for is given 10 to the power of negative 1, sorry, 10 to the power of negative 11, and the concentration for vinegar is 6.3 times 10 to the power of negative 3. You are asked to find the difference of the pH of ammonia and vinegar. So here the formula is given. So first write the formula. pH is equal to minus logarithm of concentration of hydrogen ion. Then since you are asked to find the difference of the concentration of the two substances, so just write minus logarithm of concentration of hydrogen ion for ammonia minus and minus of the logarithm of the concentration of hydrogen ion for vinegar. Then plug the given concentration into the formula, then apply the rule of uh, logarithm, which is the product property, and simplify. Then finally you'll get logarithm of 6.3 minus 3 plus 11. So the last problem is about the application. So in this lesson we have only 4 problems, so I will finish the video here. We are going to have more examples and problems in the live discussion. I'll finish the video here. Thank you very much and goodbye.